Okay, let me confirm. Yeah. So I said today we are looking at features engineering. Features engineering. Hope you can hear me. Features
Yes.
engineering. Now, I decided to bring out the topic because it's part of the plan from the beginning under unsupervised learning. But one way or the other, we have done some features engineering. If you look at what we have been doing so far, but only that we will apply. I will just run through them again and just remind us what we did that falls under features engineering, and then we'll look at some other forms of engineering. So we'll start with what is feature that we want to create using the word engineering. Now, the idea is that when you are given data sets, feature engineering involves you creating another row or creating another column. If you look at this last work we did now, I want to ask you, did we engineer feature from what I just
Yes, sir.
said now? Which feature did we engineer?
Video games lover.
Good. So feature engineering is about creating more columns or more rows in a given data set just for you to match what you want to do or to be able to standardize your model for the required analysis. So that is what feature engineering is all about. So like I said, everything we have done so far is technically a feature engineering techniques since we have created new columns or features along the way. So remember that number one, setting the correct row granularity. I'm just trying to recap where we have touched feature engineering or we have indirectly engineered feature. When we started this aspect, we started with we started with setting the correct row granularity under which we feature aggregation, aggregating multiple rows into a single row. You still remember where we use that group by function. Please, you can leave your audio unmuted for now because I'm trying to reassess what you have so you can respond to me as soon as possible. I'm asking that place where we aggregated our rows, we actually perform feature engineering there. We use a group by, and the way we also are sure each column is non numeric. We also touch feature engineering there, under which where we handle missing data, where we imputed value for the wherever we have missing value.
Yeah.
So all that we were engineering the data because we were transforming it. That is not how it came. And then we also categorical encoding, that is turning categorical value into numeric. That is feature engineering. A simple case is probably part of what we did last time, where we converted so many data type from object to integer. And then if I may just look at what we did recently, there's a place where we converted educational level. So you can see the whole of this from here. Oh, sorry. The whole of this college, graduate school, high school, we engineer different feature. After that, we now deleted the original what column. So all this falls under feature engineering. So values such as, remember when we use the function np.where if false logic to create a new indicator column. Another situation is where we use dummy variable. So all these, they falls under features engineering. Now let's look at new feature engineering techniques. So I just have to recap those ones for you to know that we have actually started this journey of feature engineering, even as we look at more techniques on how to engineer feature. So here we are looking at applying calculation. Let me use comment to applying calculation. Applying calculation. Now, what do we mean by this? You can combine column using calculation to create new feature. So that is the idea. So we are going to be doing some calculation, and at the end of the day, the calculation will generate different feature. So let's look at the data we are going to work with in this session. And it will be a data set where we have perfected it to certain level. So the data sample here, for us to get the data sample here, we are going to go to section 0 data prep code and scroll down to where we have feature engineering section. Then we copy it and paste it. And the name of the data set will be songs_gens_dictionary. So it's already prepared notebook where I've created this data set, just like the way we copied the other time. So I'll go in here and then I'll go to this slide. Then from here, this is the work book that I'm going to open where I have created it before, where I want to get the data we want to use for this session. While I was reading down, we'll scroll down to where we have features engineering. So we are going down. These are some of the things we have done. Going down, we are going down, we are going down. Hope you have that data. If you don't have it, I should be able to send it to you. And down to where we have feature engineering. Then we'll take the dictionary. There's a created dictionary there. This is dummy variable. Almost there. Okay, we've done this one. Don't know why our discount there, it was not giving us that. Done this. Okay, so this is a dictionary we're going to use. So let me copy it. Copy cell. Go to my data set. That's issue sometime to copy from one notebook to another. Might be a bit challenging. Let me. I don't know why my own is doing this. Control C. Let me use shortcut. All right. Now let me run the data. Okay, so this is the data we are using. You remember where we have this data actually. I think we have done something related to this data from the beginning. So just to be precise, so this is the data we want to use for the feature engineering. Now, if you observe this data frame has additional information. One, we have for every customer how many songs they listen to. This is the column for the song. And then the observation I'm talking about now, these are the name of the customer, and then we have the number of songs they listen to, as you can see, respectively. That is one observation. Now, while we are observing this, is for us to see whether we can actually generate different feature from this. The number. Now, so with this, let's call back our customer data. Let's call back our customer data. Remember, there's a statement that I use here. You can combine column using calculation to create a new feature. So why I brought this data is because I want to combine, remember that we are engineering new feature. So we are using this data and the customer data to engineer the new column. And that is why I said we have to call back the customer data. So I don't know where I have my customer data. Where should be customer? Let me just use that with capital letter. Let me see if I will have it. Okay, so we have it here. So this is the one we manually on our own perfected. All right, now what we are going to do here is to combine the two data sets together using the concat method. I think I used the concat method the other time. And the syntax for that, so let me say, now combine all these, we are learning techniques of engineering feature. Now combine both data frame using concat function or method. And the syntax will be pd dot concat. Hope you are with me. pd dot concat. So we are first of all selecting the customer data, then comma, then we are selecting this data that the dictionary we just brought now with the name. Let me copy the name so that it should be easier for me to see. Hope you are there. Success, hope you are following. Are you there?
Yes, sir.
Okay, all right. So I'll put a comma. I've selected the two data sets. Now remember, because of the way I am joining these two data sets, if you remember, I told you that when you are concatenating your data, there are two directions you can actually concatenate your data. You can either concatenate them horizontally or what? Vertically. Now, there is a scenario where you add what is it called? Where you add axis equals to 1. Do you still remember that scenario where you want to place them side by what?
Okay.
Side. Good. So if I don't want to place the two data side by side, there will not be need for me to
As
add the as-is. Thank you very much. All right, so to add that as-is, I need that as-is. As-is is equals to 1. As-is is equals to 1. So like I said, this is to enable us to place the two data frames side by side. Now, after this, let me run this and see. You can see that we have successfully concatenated the two data frame. This is where the first one starts, and this is where it ends somewhere. But if you look at the entire data set, we have them concatenated. Now, but there is an observation here. There's an observation here. These names, the names are common in both data sets. This is a customer. You have what? This set of name. Now look at this one. You also have what? The same set of names. That is the reason why we find it concatenatable, because admittedly they don't have some things in common. It wouldn't have been possible. Now, observation here, customer column is extra. So the next thing is for us to drop it. This column is extra. So we have additional of it. So we already have it under name, so there's no need. So this become extra. So we need to eliminate it. Now I want to ask you from what you have learned so far, how will you drop that particular column? Which function will you use? Not sure if success is with me. So observation here.
the drop function.
Okay, observation here. We notice that after concatenation, comma, customer column is extra. Therefore, it should be dropped. Therefore, it should be dropped. And to drop it, let's look at the syntax. To drop it, the syntax will be pd dot concat p dot concat. Then we are selecting customer. We are selecting the customer again, then comma. I don't know if I pasted something, if you notice it to be there. Okay, good. The next data set, then comma, as is equals to 1. Then after closing this, you now concatenate the dropping function outside the concat. That is, what you are saying is that join those two data sets together, then you now what? Drop. So that is why it's coming outside. So drop, like you said. So drop is a function on its own. Then you have to specify what you are dropping to be columns. Columns, that is an attribute. Column equals to, then you select from the data set, you select the particular column you want to drop, being a string. So you select customer as the label you are dropping. So you can copy it here to be on the saver side. Then I paste it inside. So this is going to automatically remove. Let me run my code. Now I have been able to drop the customer column from here, and I have just the name. Hope that is clear. Now, note, you can see that all values from age are numeric that can be used for modeling. Now, are you with me? There is still an issue. There is still an issue. The customer that we call, success, are you with me? I want us to notice this together.
Yes, sir.
Good. There is still an issue. The issue is that we did not actually work with the updated data set where we have dropped this before. Remember, we have dropped this after generating college, graduate school, high school. We later dropped this. So we have to drop this now because we are supposed to work with that data. Maybe somewhere we missed it. Maybe the customer
The
I
name of the
selected.
data is still customer.
And that means I did not update it to the one that I have removed. I thought we did that day now. So, but I thought we did something like that. We did something like that. I'm very sure. But if I could not find it, we will just drop it now. I think from here, yeah, we did something like that. Okay, you see the challenge now. We did not save it back. Have you seen our error? This is the column. This is our error. So we are supposed to save this back with this. Let me see if I update it. It will give us the correct one. So now we are supposed to hope it will not throw error. Let me see if I correct it here and run the code, I should be able to. What is it saying? Level not found in what as is. What is the did it throw this error? Not found in the as is. Let me run the code again and see where. So I'm trying to see if we can adjust it and proceed with it. If it doesn't work, then manually we have to follow the same code and select that and remove it. Here's that this where we're working on. So let's see. Here again, we did not use the customer here. We did not use the customer here. We did not use the customer here. Where did we use the customer? Okay, here we use the customer. I think this is where we use the customer. So let me rerun this particular and see whether it will remove it. Okay, I think we are good to go. So it has been removed. Are you with me now? So we have removed.
Yes.
Okay, now, so let's look at that observation that I was talking about. Observation, you were asking me the other time that why are we creating this dummy variable? And I told you because we found out that there are still some features that are not numeric data type. And for what we have done so far successfully, from age down to rock, they are all what? Numbers. They are all integer, which is a perfect model for analysis. Now, like I said, you can see that all value from the age are numeric that can be used for modeling. Now, we'll save this as a new data set so that we won't have that issue we're having now. So we save the whole of this as a new data set. So I was trying to write the note that now.
Let me see the last code. Thank you, sir.
All right. So the next step is for us to save the above. Save the above output as new data frame. So I will just save it with a name called model, since we said it's ready for modeling. So always use names that will assist you to understand what that data is prepared for. Model, then equals to, so let me copy the whole of this code, Control C, and then paste here. Done. Now, if I want to view it in the new data frame now, I'll do model df. Okay, so we are good to go. So what exactly do you think we have done? Have we actually successfully engineered new features on this data set? I'm asking. Success. Whether it's network, I don't know. It's taking you time to respond. I am asking that, have we actually created new features with what we have done on this data?
Yes, sir.
All right. Because that is what we are learning now, how to engineer different features. And I started by saying that you can combine two data sets together. And that is what we did. So we re-engineer the data using we engineer new feature using the concat. So let's take note of that. So the next thing we are looking at now, we're still under creating. The next thing is create a new column for pop. Create a new column for pop or percentage of pop. The pop is one of the pop is this is this. So we want to create percentage. So all these are just techniques on how to create new feature. So the code we are going to use, so we want to first of all select it out, want to bring it out because that's the focus now. We want to create new column that we calculate the percentage of the value we have under pop feature. So just to call it out, remember some of the techniques I must have shown you. Underscore df, because it's in this data frame. So I will just say what? Pop. Remember I said you can also use square bracket, but where is single word like this, there's no space. If it is multiple word where you have maybe pop space another name, then you don't use dot, you use square bracket to pull it out. So if I select now, so you can see what I've done with what? Just model dot what? Pop. Now, what this function did, what we did now, we just call it out as a number of pop song they listen to. That is what you did with this. But I think what we are getting is different. We actually use another function because the pop is not spelled. That pop is a function in Python. That is why it displayed that way. So we need to copy our pop feature, not this function. So it did a kind of analysis for us. So that is not the one we need. The one we have in our data frame is capital letter P. So let me call it out. So this is what we expect to get. So if I want to put it in a proper index, I'll also do dot what? Reset underscore index, so that it will display proper for us. Now, the next we want to look at is, because of the space, you cannot use, so we are also looking at, remember our statement here, create a new column for what? The percentage. And we have just called it out. So the next we want to do is the number of songs that they listen to. Where is it? We have a column called what? Number of songs. Number of songs. So what we are going to do here is to also select it out, because the feature we want to engineer is related to these two columns. That is the reason why we are selecting them. Remember the main topic, calculation. Calculation. Let me go to where we started, because that's where we are going to. Before we called in this dictionary, we said applying calculation. So we first of all concatenated two data frame, and from those two data frame, we want to perform a kind of calculation of the percentage of pop using two columns, the number of songs they listen to and the pop value. So we have just pulled out the pop value, and then we want to also pull out the number of songs they listen to. Then we will now end up dividing the pop result by the number of songs they listen to. That is the calculation there. And that will give us the percentage of pop. So the next thing I'm going to do here is to also call out the number of songs. That's my hash. Number of songs they listen to. So, and the syntax I'm using, the syntax I'm using is from that same model, that same new data we created. That is where we are calling this number of song data from df. Now, like I said, we cannot use dots, because if you look at the number of song as a feature is double description. There is hash there, and there is space between the hash and the song. So why we use just dot? Because the whole of this, they are together. But where you have space like this, you have multiple description, then you can't use dots. Or even if it eventually works, the best practice is you use selection bracket like this, and then select it as a string like this. So let me bring it out. So I have this. So like I also did the other time, if I like, I can index it properly. But that is not my focus. Now, therefore, to divide, therefore, to divide pop by number of song, the syntax we are going to use, syntax will be, we call that data frame df. So what we will have done is to copy it, dot pop, then divide by this, the code that generated this. So let me not waste my time. So I'll take the whole of this, Ctrl C, and then paste it here. Then after this, I run it. So I've got to my division. So this is the calculation now. So you can do times, you can do addition, depending on what you want to do. But the idea is we are still working with that topic that say calculation. That is generating new feature based on certain calculation. Now we divided this, and the answer we are going to get will be saved as another new heading. That is the idea. So this is the percentage of pop that we talked about somewhere here as a way of generating new feature here. Here is it. Here, applying calculation, you can combine. So now we have gotten our calculation. So the next we want to do is to save it. Save, because we are going to use it, so we have to save it. Save the division. Division results in a new variable. So trying to explain so that to be clear to you. The syntax, we will just use model underscore df. Remember, this is the syntax when you are creating a new feature in an existing data. You select that data and then you select the new feature. So I'm quoting it with percentage, that is PCT, that's percentage of pop. So that is the new feature we are engineering. Then equals to, then we will now save the whole code that generated the division results. Copy it and then paste it. Then all I need to do is to call the model underscore df again and see if I have it here. So you can see. So with this, let's see if we have actually created or engineered new feature. Have we engineered new feature? Please check.
Yes, sir.
Which one is the new feature that we added?
Percentage underscore pop.
Good. So you can do other kind of calculations. So the idea is that as a data scientist, you can be given data whereby you have to do all these readjustments, where you have to take two sessions of data set, concatenate them together, then use one to perform calculation against the other, and then you can now create a new heading using the calculated results. I want to be sure that it's clear to you.
Yes, sir.
Okay. All right. So you can use other mathematical operators like multiplication, addition, subtraction to perform different calculations that will end up generating new feature. So that is the idea. So you can see that if we have not converted all our features value to integer, most of this calculation we are doing right now will have been a bit difficult. So that will take us to, I'm trying to a kind of rush you because of, I told you that I'll be traveling. So I want to see how I can compress this class since you have access to the video to take your time before I come. I'll try and record another one like you said and send to you. Now, we want to look at binning values. Binning values. Now, one thing I want you to be observing as we are learning, the terms and the functions. So what we are doing is just like I'm exposing you to these functions, the technicality that are involved in data science. Now, binning value is the next topic, binning values. So in case you want to know what is binning value, you can group numerical feature. Let me use comment. Let me try. I don't like typing, but let me type so that it will be easier for you. So you can, so you understand the concept of these binning values. you can group numerical features into beings or discrete. That is another, or discrete category. By the time we are through with the application, you understand the full meaning of that binning value. Categories. If it make more sense for you or for your analysis. Now, let's select name and sign up down from the data set. That is, we are selecting this name and sign up. We have a place where we have sign up. Here is it. There are two columns I want to work with here. I hope it's this data. I hope it's this data. Let me see, because I can see name. Let me see if this. Come here, let me sort out the data. Not to be sure that working. I said you can group numerical features into bins or discrete category if it makes sense for your analysis. So it's an optional thing. So the first thing I want to do is that I want to bring out the two features that will help us to perform this particular operation, such as the name from this data and the sign up day. So how do we select these two? So whenever you want to select more than one feature or column from a particular data frame, the syntax you're going to use will be this. So let's say syntax. Hope you can hear me, please. Syntax.
Yes, sir.
For multiple features. Selection. So the syntax is, I will call the data frame itself model underscore df, where I'm selecting two sub features from. So you type it, you open the square bracket 2 times, and then you now call the headers that are involved. The first one is name, and they are all string. So just to be sure, let me copy from the data frame. Then, comma, you're actually wrapping the two features inside the inner square bracket. So another feature is this. This is what we are taking. All right. Now, if I hit enter, this will bring name model is not defined. Oh, there's a mistake here. No L here. All right, so with this, we have called out the two data sets we want to bind together, we want to group together. Now, the next thing we are going to do is to create an indicator for weekend or not. Now, look at this. These are the names of the students, and these are the days, the sign-up days. So these sign-up days, these three could represent March. These two could represent, if Sunday is 0. If Sunday is 0, what day do you think the three should represent? Sunday is 0, Monday is 1, then Tuesday is what? 2, and then Wednesday is 3. So that should be 3. But we need to use discrete number to represent them, because it will make the model think that this one is better than this. So what we want to do is to use that np.where to convert this. So we're going to use Python logical function again here, where we will group, because that is the idea. We will group some days and say if it is so day, it should be 1. Then if it is so day, it should be 0. That is the binning value we are talking about. That is grouping, categorical data, or discrete, if it makes sense. So the idea is for you to understand this logic. Now, let me use comment to explain what I want to do. Create an indicator. Create an indicator for weekend or not. So create an indicator for weekend or not. Now, but you have to remember, while you are doing that, remember 0 will be equals to Monday. So you set, according to programming, the first item in an array will always be what? Index what? 0. So we can start with 1. Then 6 will be equals to Sunday. Then 5 will be equals to Saturday. So bear this in mind as we bin this value. So therefore, it is one of those. Therefore, if it's one of those, it will be weekend. That is what we are saying, which should be assigned 1. So if it is weekend, it will be assigned 1. If not, or if it is weekdays, it will assign 0. That is what we are trying to do here. So at the end of the day, all these numbers, we want to convert them to 0 and 1. And we are separating weekend from weekdays. So if it is from what I just gave you now, that if 0 is Monday, and then 6 is Sunday, and then 5 is Saturday. So at the end of the day, if it is weekdays, it will assign 0. Then if it is weekend, it will assign 1. So the code to achieve that would be this. So syntax. So we'll call our data frame model_df. Then I will select. So I'm creating a new feature here now, which is a string. I will say weekend. Weekend is equals to np.where, because we are using Python conditional statement. Where is a function. So where customer, that's the data we have this information from. Where customer, from the customer, we are selecting sign up sign off day that will determine the assignments. So just to avoid error, I'll copy it, paste. We are selecting this. Then outside the bracket, we are still inside the where function. You concatenate, that is dots is in. So it's a function. Now inside that function, we are selecting the number we are grouping. The number we are grouping. So 5, 6, comma, will be assigned 1 or 0. So if you look at what we have done here is the interpretation of this. 5, I say 5 is Saturday. And 6 is also Sunday, which means that these two, they fall under what? Weekend. And then if it is weekend, it will assign 1, like I told you before. Then if it is weekdays, it will assign 0. I want to know if you understand it to this level first.
Yes, sir.
Okay. Just a minute. All right. So let me run the code now and see what we get. So we get it registered. Now to call out the data set to see if these assignments have taken place, I'll simply call the name of my data set. Ctrl C. So let's go back to the data set now and see if the updates has been implemented. Remember, we engineer new feature, right? What is a new feature? Let me try and reduce my screen. I want to see if we have the new feature. Yeah, we have it here. Weekend. We have generated the new feature, weekend. And where we have all these 0, what does that represent? So how many weekend do we have here? We have what? Students who sign up Sunday or what? Saturday. I think there are just 2 from this. There are just 2. That students sign up what? Weekdays. Okay, so this is actually the Bini value. What is the essence? This is what I'm trying to explain. This function is in. So this is what you are actually using to group, to select the 2 category of the days or the discrete numbers. And then you are assigning, if it is not this, it will be this. Then if it is this, that's why we first of all understand that the number of days could be represented with discrete number, such as 0 and 1. Okay, so now the next thing we are going to do, we are going to drop one of the column. And I want you to tell me the column we are going to drop. One column is no longer useful after converting to this, after binning this value. One column is no longer useful. Can you identify the column for me? Can you identify the column? There's a column we don't need now because we have used its value, or we have a different representation of what we have in that column, which is the best for our modeling. So we no longer need that column. I want you to identify it for me.
Sign up day.
Good. Sign up what? Day. We don't need it again. because now the information this was giving us is confusing. This 3 now, it means it's Wednesday. We don't know. This 2 now, whether it means February or it means Tuesday, we don't know. So the model might think that 2 is better than 3 or 3 is better than 2. So the best thing is for us to bin the number here by grouping them. Like I said here, by grouping them using a discrete number to represent the weekdays from the weekend. So we drop it. So so therefore, just give me a minute. So no. Okay, so therefore, drop sign of the because they are now represented in weekend column. So to drop it, can you give me the syntax? Model underscore df, that's the data frame where you have it, dot drop, then column. You have to specify what you are dropping, columns. Even if it is 1, you have to write columns. Equals to, we select the feature. Let me go and copy it to avoid the typographical error. Ctrl C. Are you sure I've not made mistake there again? And then copy. All right, so let's call the name of the data set to see if the updates have taken place. Ctrl C. So I think we should have dropped that. It has not, because I'm seeing they still dropped the here. Any mistake. Drop columns equals to should have dropped it now. How come it's still there? Or drop there, shouldn't be there. We're having 2 of them before. I don't know. Let me see. Model underscore drop columns sign of the correct. Okay. So we are supposed to save it again. I think I've seen where the error is. So, so we are supposed to equals to. This is how we are supposed to run it, to update it. Hope you understand what I did now. Just like we are storing the whole of this into this. So what I did before, I did not update it, so it was still calling the previous one. So what I've done now, I have saved the whole of this code, which must have dropped this inside the same data frame. Now, if I call the data frame now, I should be able to get the updated version. The one without the this. What is the error again? Let's check. Sign up date not found in as is. Okay. Oh, we have sign up date not found. How did we corrected this? Let me run the code. I think that was how we corrected it the other time. Okay, let's check. All right, I think it's okay now. So you can see that we have removed the sign up there. Yeah, we have removed it. Did you understand it?
Yes, sir.
Okay, so when you are having this issue, you should know what to do. What I did was when it says it could not recognize it, I have to run the code again once you are sure that your syntax is correct. So now we have replaced that. So the next thing we are supposed to talk about is identifying prosy. So maybe I'll start the recording from there so that it doesn't get too much. So you go and practice this one first. Or what do you think?
No, can continue.
Okay, all right. So let's look at identifying. Identifying prosy. Variables. Identifying prosy variable. So what is prosy variable? A prosy variable is a feature meant to approximately represent another variable. Now, the idea is that you might have, in the process of trying to engineer new feature, I want to be sure that I'm recording. Okay. In the process of trying to engineer new feature, at times, like this case now, we were able to combine two data sets together. That was the what we did before this one, before the binning number. But there are times that you may have to reach out to another data that have a variable that is equivalent to one of the variable you have in your current data for better representation. That is where you bring in this proxy variable. Like the definition says, a proxy variable is a feature meant to approximately represent another variable. So for example, here now we have another, they are used. Okay, let me just add this note so that you understand it very well. They are used, and you know why there's need for you to do that. They are used when a feature is either difficult to gather, or sorry about that, I think that should be next. Either difficult to gather or engineer into a new feature. So that is where you involve proxy variable, another equivalent that you can bring from another data set. So I have a data set here, which I'm going to load in a moment. And this data set has a name, which is equivalent to the data frame above. It also have sign up months and then average temperature. So the idea is that we have found out that it's difficult for us to generate a new feature from this particular data set. So we are considering another data set that has value that could influence the performance of one of the feature in our current data. So we will now use that value or that feature as our proxy variable. That is, this value in another data set could determine why this value in the current data set is happening. So like the example I have here, we have the sign up month. The sign up month is numeric, but may not be good for modeling. August is not better than May. So let's look at what we are talking about here. This is sign up month. Just like the reason why we use the logical function to group the sign up days into 0 and 1s. Now we are saying that that same scenario can also happen to this. Because if this is May, this is August, the model will be confused that whether to have a kind of priority over August over what May, or May is better than what August. So for that reason, we are going to engineer another column, which is going to be average temperature. So the idea is that the sign up month here could be influenced by the average temperature. So we are saying that the average temperature can be a proxy variable to sign up months, which means that it can be the temperature, the weather determine the months, maybe the atmospheric condition of each of these months determine the sign up month of the students. So that is what we are trying to compare here. So let's see how we can bring in that data set that have the average temperature, which is going to act as our proxy variable that can be equivalent to what we want to do. So like I said here, the average temperature each month, you may not be able to engineer proxy variable from existing data, but they can be gathered from external source. That is what I have explained so far. So to get data from the external source to generate my proxy variable, so we will go through this same step. So we are going back to that section 3, data prep code, where we copy the other dictionary from. We will scroll down to where you have external data with the average temperature in Fahrenheit, that is in F, that is unit. Then each month in Chicago, data set name will be average underscore temps underscore dictionary. So we are going back there. So let's come here. So let's scroll down. The data set that have the proxy variable we want to use is what we are looking for now. And the name of the dictionary will be average underscore temp. So which is this? So we are taking this and we are going to add it up. So we are taking this variable to replace that sign up month as our proxy variable. So I want to be sure that you are getting this idea of proxy variable before I continue. Are you getting it?
No.
Okay. But if I did not ask now, you wouldn't have said anything. You are just looking like you go and watch video.
Yeah.
And now what we are saying here is, let's start by knowing the essence. What is proxy variable? How did I define it? Let's go back to our data here. A proxy variable is a feature meant to approximately what? Represent another variable. They are used when a feature is either difficult to gather or engineer into a new feature. What is a feature that is difficult for us to engineer into a new feature here? Is what? The sign-up month. The same thing happened to the sign-up day. It was difficult for us. So what we did is that we have to perform a calculation which helped us to what? To group it, to bin it into what? Weekend. Now, the same scenario we are relating here, that this is also difficult. How would the model know that this 5 represent May, this 6, this 8 represent August? So the model might think that May is better than August. So what we are doing is that since this cannot be easily engineered into a new feature, so we are involving a proxy variable. And the proxy variable is meant to represent one of the variable in your current data set that is difficult to engineer into a new feature. Did you understand it to that level first?
Yes, sir.
Okay, so now with that understanding, we are now traveling to an external data set, external source, to bring in another column with values that can be equivalent to the sign-up month. But our own understanding here is that why are we considering average temperature for, or why are we considering average temperature as our proxy variable? A variable that is meant to represent another variable that is difficult to engineer a new feature. Because the sign-up months can be determined by the average temperature. Remember that this data set now, we are not considering Nigeria. We are considering Chicago, where they have all this tough weather. So we are assuming that the student register to watch those videos or to play those songs, that registration or that sign up could be determined by the temperature. When the temperature is very high, they may not come out for that. So that is the reason why we are saying that, okay, it means that average temperature can be a proxy variable toward sign up month variable. Is it clear? Are you with me? Did you understand that establishment first before I move on?
Yes, sir.
Okay. So now we are taking this data. We are taking this data because this is where we have our proxy variable. So let's go back to run it. So we have it here. So now what we are going to do, we are going to merge. Now we merge or join the model underscore DF and average underscore temperature. So here we are introducing another function called what? Merge in the place of what? Which of the function we have used so far that has a kind of similar action with this merge?
Okay.
Good. So the idea is that I'm introducing different functions. So where you don't want to use concat, then you can use what? Merge. So all this exercise is to familiarize you with all these Python function or library functions. So now, like I said, let me use comments here to explain it. Please, anytime you don't understand, please better speak out. For you, nice. I read that is silent. So now we merge or join the model underscore df my hand and avg underscore terms. So the syntax to do that, so let me add using a merge using dot merge. It's a function. So we'll start with PD dot. Why are we calling PD? Why are we calling PD success? Are you here?
Yes, sir.
Why are we calling PD? You are looking for the answer. Why did I call PD? If you can hear me, please respond to that question.
Because you want to import it and use it for your model.
Because the merge function is from which library?
Pandas.
Good. I mean, you are acknowledging that this function is in this library. That is why you are, first of all, acknowledging it. Okay, now we are joining two functions, two data sets. So let me copy this to avoid mistake. Now you can see that the same syntax with what? With concat. This was how we used concat too. We separated the two data frame with comma. Now, after this, but in the case of concat, there are some attributes we did not use, which we are going to use here. And the reason why we are using these attributes that I want to introduce now, which is called left underscore on equals to. Okay, let me type it. I will explain it for you. explain it. Then I'll bring in the sign up months. Let me copy to avoid mistake also. Even after everything, you should be able to understand it by yourself. I'll ask you first whether you can interpret it. Right underscore on equals to this shouldn't be here now. Equals to months. So let me test your understanding. Do you understand what we are doing here? Can you interpret what this left on and right on are doing?
No.
They are attributes. Now, from the value they are storing, you are determining the order where, we are merging two data sets together, right? And the two data sets we are merging together, we are focusing on two headers, actually. Look at this here. This particular one that you brought here has months, right? And then has the average what? Temperature. Now, the column in DF has a sign of what? Month. So when you say sign up, you are just stating where they should be added, as in the column positioning. You are saying that one should be the sign up should be the left, while the what after merging, then the month should be by the right. Now let me run it and see the result. Maybe from the result, you will understand it properly. So you can see what has happened here. What you have under what? Sign up months. They are now represented as what? Months. Because at the end of the day, we are taking off this. Then the temperature is now standing on its own as average what? Temperature. That is the meaning of that. Now you can see, you can clearly interpret here now. So what this place did is to take this value and place it here, and then take this one and place it here. So what you are doing is you are trying to like determine the positioning of the columns that are involved. Okay, so now we have merged them together. Remember, the average temperature is proxy for what? Sign up. Let me put that statement here so that it's clear to you. That was what I was trying to explain the other time. So remember, the average. So you know which one is the proxy variable here now. The average temperature is a proxy. It's an alternative proxy for sign up. Sign up months. Because in a model, need to write this statement to enable you to understand the whole concept. Months, because we cannot put the sign up months in a model. Why? Because the model will, we think, for example, we are just picking this, we think September is greater than June. So this is what we are avoiding by bringing the proxy variable. So therefore, we are using proxy variable or another variable from an external data to approximate the essence of the sign-up month. So my hypothesis is that sign-up months depend on weather outside, which is why we brought in the average, just like what I've explained. So our conclusion is just like we are saying that the sign-up months depend on the average temperature. That is why we could link them together as proxy variable. Okay, so there is a particular column or feature we need to drop. Can you identify it?
Let me see the headers.
Yeah, okay. Now that we have created our proxy variable, there is one that is no longer useful that we need to drop.
The sign up month.
The sign up was months. So we drop it. So let me just add that note. Therefore, we don't need the sign of months. So syntax, drop it below. So we'll simply call model the data set itself where we want to drop that particular feature from is equals to model, so that we can update it, underscore df dot drop. So by now you will have noticed the format for dropping. You call what? Columns equals to, you select the particular column is a string. So let me go there and copy it. Control C. Then just to update, let's call model underscore df again. So let's check. I think we'll have removed it. So we have removed them. Okay, so successfully removed. So you can see how we have engineered different features. That is just the technicality we are learning since. So an overview of feature engineering tips. One, anyone can apply an algorithm, but only someone with domain expertise can engineer relevant features, which is what makes a great model. Number two, you want your data to be long, not wide. Many rows, few columns. That is one of the reasons why you should engineer new features. If you look at this, our data now, which one is long, which one is wide? You can see that we added this, we added this. If we want to look at what are the features we have engineered so far. The data set didn't come with this, so we are the one that added this. We engineered it, we created it, and then also this. Is there any other one that we created? Or this one?
Only
Hmm? Okay. So with what we have done so far, so remember to one, try to collect as many observations, such as rows of data, as you can. Two, only select the most meaningful feature for modeling. That is the reason why we are learning all these different techniques on how to select. So that when you are given data set and there is need for you to reduce the column, to reduce the height and increase the width. So you have knowledge of all these functions we are using. So far, if I'm to focus on some key functions that we have learned so far in the process of trying to engineer different features, we learn concat, we learn what is in, we learn merge and the rest of them. So once you start modeling, you are bound to find things you missed during data preparation and will continue to engineer features. So that is the essence. Once you start your modeling, you will now begin to see things that you miss during data preparation or entry. And that is what is actually leading to engineering different features. If everything was collected perfectly from the beginning, there wouldn't have been need for engineering different features. So I have an assignment for you here. This should be our fourth assignment. And this assignment is to enable you to understand the whole of this feature engineering aspect. So what is the assignment? Let me write it. Assignment. I'm very sure this should be your number 4 assignment so far. Finish typing. It will not convert. So from Egwero Prosper. Later. Hi. We is apostrophes. Use comma. We did like to add new features. Before we begin model. And you create following column that sum up the total hours of entertainment each student consume weekly. A column, you create another column again, column that calculates calculate the percentage of entertainment consumed that is consumed on, how do I put this now? That is on screen. So this is just like an email as a remote staff. This is just like an email sent to you. Thanks again. Prosper. So just to guide you, the key objective of this assignment, what you should look out for. The key objectives are: number one, create column called total underscore entertainment. That sum of all types of entertainment for each student. Number two, key objective, create a column called, so you can see that all these are feature engineering tasks. So just creating column. Screen that calculate calculate the percent for percent of entertainment. Screen. Every except set for book. For each student. So that is the assignment. So the data you are going to use is different. So what will happen is, just like we have been doing it, we will do it as we do it in the class, then you go and do it again. Because I don't think you should be able to do it because you don't have the data required. Can you hear me?
Yes, sir.
Okay, so our next class, I will start with this assignment solution. Maybe it's part of what I will record and send to you. Then you make sure you do it. Are you with me? Or you still have time, you should do it. Precious Success, are you here? Hello? Hear me?
Okay.
I was asking if you were hearing me before, but the network signed me up. Were you hearing me before?
You said we start from here by next class.
I said it's part of what I will record and send to you. So you replicate it.
Okay, sir.
You are still going to work now.
Yes, sir.
Okay, so we stop here. So I will record the assignment solution, and then we'll also, and if I can, start another topic. Once I've sorted out the assignment, then I'll send you all. So, but before this assignment, everything that we have done, you have to perform. You have to first of all take that as your first assignment, starting from where we started from today. I think we started from somewhere here. No, not here. Not here. We started from, is it here? I thought there was a feature engineering now, right? Features engineering. So this is where we started from. So before you implement the assignment solution that I'm going to send to you, you will have performed from here down to where we stop right now before you continue with the assignment. Is that clear to you?
Yes, sir.
All right. Have a nice day. Bye for now.
Thank you. You too. Bye.